Good evening, dear students. So we have started with thermodynamics in the previous class, right? So we have dealt with the synopsis and we have solved some MCQs based on this, right? So these were the things which we have discussed in our previous classes, right? So we have studied the type of processes and all. Okay, so we have seen the relation between CP and CV. Okay, so we'll see the equation only. Okay, we are not going to go through the depth of the your equations. Okay, so just we are going to see the last equation. We are not going to solve the uh, okay, so here you can see relation between CP and CV. It is given by what? It is given by CP minus CV is equals to R. Okay, so remember this. And the this heat capacity, it is given as what? It is given as Q is equals to, okay, it is given as C into delta T. Okay, that is change in heat energy. So these are the things. So enthalpy change of a reaction minus the reaction of enthalpy. Fine. So in the chemical reaction, reactants are converted into products and it is represented by, so this is the equation that is the RH, okay, small RH is equals to summation of HP minus summation of HR, okay. So these are the things which you need to remember. Now, what is standard enthalpy of reaction? Okay, what is standard enthalpy of reaction? So the enthalpy of reaction, okay, is the enthalpy change for a reaction when all the substance, okay, in their standard state. So when all the substance are in the standard state, then they are called as what? It is called as the standard enthalpy of reaction. Okay. So here all the your this what all the substances are in the standard state. So the standard state means what? It refers to the existence of a substance in its pure form, that is at 1 bar pressure and at 298 Kelvin temperature. Okay. So this is about standard enthalpy reaction. Now, what do you mean by standard enthalpy of formation? Oh, okay, it is given as delta small f H naught. Okay. So it is a standard enthalpy change for the formation of 1 mole of compound from its element in their most stable state. Okay. So it is denoted by F H naught. Okay. Those, so for the standard enthalpy of formation of carbon dioxide, so the enthalpy change will be 1 mole of carbon dioxide is formed. So how 1 mole of carbon dioxide is formed? From one, that is from a carbon and O2. Okay, at 298 Kelvin, that is a standard temperature, 298 Kelvin, and okay, temperature and 1 bar of pressure, and all the substances will be in their stable state. Okay, so this is the meaning of standard enthalpy. Okay, so all the substances will be in their standard states. Okay. So this is about the enthalpy. Now, so whenever the enthalpy, when you are talking in terms of phase transition, how phase transition occurs, okay, that is the substances will change the phase from one phase to another. Maybe from solid they are changing to liquid, from liquid they are changes to gaseous, okay, or from solid they might be going to gaseous state. So this is the enthalpy change. That is when 1 mole of a substance changes from one phase to another phase at a particular temperature. So the type of enthalpy phase transitions, they undergo by three types, that is enthalpy of fusion, enthalpy of vaporization, and enthalpy of sublimation. Okay. Now, what do you mean by enthalpy of fusion? So it is the enthalpy change when 1 mole of a solid substance changes to liquid state, okay, as its melting point. So melting of a solid is nothing but it is an endothermic process. Okay. So all the enthalpies of fusion, they are positive. So always the values will be in positive form. Okay. Now, enthalpy of vaporization means what? When enthalpy change occurs from one mole of a liquid substance changes to directly to its vapor state, okay, as its boiling point, then it is called as enthalpy of vaporization. That is, your liquid state is undergoing change to vapor state. So this is enthalpy of vaporization. Then what is enthalpy of sublimation? Sublimation is what? When you are solid, okay, so when the enthalpy change occur from one mole of a solid substance to directly it undergoes gaseous state, okay, it will not go through liquid state. So from solid directly it will go to liquid state, okay, and a particular temperature below its melting point, then it is called as enthalpy of sublimation. Okay, so these are the things you need to know. Okay, so based on this, we'll be solving the questions. Okay. So next is Hess law. So this is also very important, Hess law. Okay. So what is Hess law now? Hess law is nothing but the law states that the total enthalpy change for a physical or a chemical process is the same, whether the reaction, whether it is taking place in single step or in the several state, but the total enthalpy change will remain the same. Okay, and the total enthalpy change for a process, it is independent of the path, whether you are going directly or you are going indirectly. Okay, the product form will be the same. The enthalpy change, it does not depend on anything, it is independent of the path which is followed. Okay, so according to Hess law, if a reaction takes place in several steps, then its standard reaction enthalpy is the sum of the standard enthalpies of the intermediate reactions. Okay, so it is illustrated here. So you can see the diagram here. Okay, so how it is illustrated? So if you're considering a process where the reactant A, okay, is converted to product B in a single step. Okay, you can see that directly your A product is converted to product B. Okay, reactant A is converted to product B in a single step by involving the heat change by delta H. Let the same reactant A, okay, is first converted to B. Sorry, C. So what you can see, so first in one single step, A is converted to B. Okay, now we are assuming that A is converted to C by changing delta H1. Okay, then from C it goes to D by involving the heat change of delta H2. From D, it is undergoing the change to C, so B. Okay, so it is undergoing the several steps. So from to form the product A to B, it is undergoing the change from A to C, C to D, and D to B. So this involves the heat changes, that is delta H1, H2, and H3. Okay. So according to Hess law, whether the reaction is undergoing in single step or the several step, okay, it is independent of the path. So delta H is nothing but delta H will be summation of delta H1 plus delta H2 plus delta H3. Okay. So this is according to Hess law. Hess law is nothing but heat summation. We are taking the summation. We are adding all the heat changes. Okay, whether it is taking place a single step or it is undergoing the change in a several step. Okay, so it is we are showing the heat summation. We are taking the heat summation. Okay, next. Thermochemical equations. What do you mean by thermochemical equations? Nothing but a balanced chemical equation when we are writing the value of enthalpy of reaction. Okay, it is called as thermochemical equation. So here the for each reactant and product, okay, we are writing the physical states. Okay, so you can see G, okay, that is nothing but gaseous state. So we are writing the physical state of each reactant and product in the bracket form. Okay, so this is the how we write the balanced thermochemical equation. So how much heat is evolved, okay, that is how much heat is given out. So delta H, that is change in enthalpy, it is plus 2585.83 kilojoules per mole. Okay, now enthalpy of combustion. What do you mean by enthalpy of combustion? Combustion means burning process. Okay, that is when your one mole of substance is completely burnt, okay, in the presence of excess of air or oxygen. So all your reactants is and products should be in the standard states. Okay, so this that is standard enthalpy of combustion is always negative because heat is always evolved during combustion. So you know that whenever it is undergoing combustion, heat is always evolved. Okay. So this is a your values will be negative here. So you can see here methane plus O2, okay, oxygen. So you know for combustion, okay, when your hydrocarbons or so you're there, it is taken as methane. So methane, when it reacts with excess of oxygen present in the air, it forms carbon dioxide plus water molecule, okay, plus heat and light is given out, okay. So this is about enthalpy change. So enthalpy, sorry, standard enthalpy of combustion. So whenever combustion means what? Burning. Okay, burning takes place in the presence of air. Now, standard enthalpy means it is the enthalpy change when 1 mole of substance is completely burned. You have to consider 1 mole. Okay, it will be in standard temperature and pressure. Okay, so so this will be according to standard temperature and pressure. Fine. Next is enthalpy of atomization. Okay, atomization means what? The enthalpy change takes place when breaking of 1 mole of bonds completely to obtain atoms in the gas. Okay, so we are breaking 1 mole of a bond completely to form atoms in the gaseous phase. Okay, then it is called as atomization. So if we have a diatomic molecule, suppose we have oxygen, O2 molecule. Okay, so the enthalpy of atomization will be same as the bond dissociation enthalpy. What do you mean by bond dissociation enthalpy? The energy which is required to break the bond, okay, between the oxygen atom. Now, oxygen diatomic state means what? Oxygen will be in its O2 form. Okay, so this is a diatomic. So the energy which is required to break this bond, okay, O2, it is there is a double bond in between. So the energy which is required to break this bond between to dissociate these two atoms, okay, it is called as bond dissociation enthalpy. So you can see it. H2 molecule. It is given as H2 gas. Okay, when it dissociates to 2H, that is two hydrogen atoms, gaseous state. So the amount of dissociation or the enthalpy of atomization is given as 435.0 kilojoules per mole. So that is the value. Now, what is bond enthalpy? Okay, bond enthalpy means what? It is the energy. Okay, the chemical reactions involves the breaking and making of chemical bonds. Okay, so the energy which is required to break and break the bond, okay, and the energy is released when the bond is formed. So enthalpy of bond dissociation is positive, and always the enthalpy of bond formation will be negative. Okay, dissociation means breaking of bond, the value will be positive, and making up of bond, that is bond formation, the value will be negative. Then what do you mean by bond dissociation enthalpy? Just now I told you that is the heat required to break 1 mole of covalent bonds to form product in the gaseous phase. Okay, it's called as the bond dissociation enthalpy. Fine. So these are some of the important terms which you need to know. Next is lattice enthalpy. Very important, lattice enthalpy. Lattice enthalpy, it involves for the ionic compounds. Okay. So when 1 mole of ionic compound dissociates into gaseous ions. Okay. So we use your this lattice enthalpy from an experiment which is called as Born-Haber's process. Okay. So according to Born-Haber's process, this particular what you can say and lattice enthalpy can be explained. Okay, so we are taking an example. We are considering the formation of a simple ionic compound, that is NaCl. You know NaCl compound. Okay, ionic bond is what? Ionic bond is sharing of electron takes place. Okay, Na plus will give the electron, Cl minus will take the electron. So sharing of electron takes place. Okay, sorry, transfer of electron takes place. Sharing, not sharing, transfer of electron takes place. So Na will give the electron and Cl will take the electrons. Okay, so transfer of electron takes place. So first step involves the conversion of solid sodium atom to gaseous sodium atom. Okay, so the energy change involved in this process is called as sublimation, because your sodium, okay, which is solid state, it is undergoing the change to directly to gaseous state. So what it is undergoing? It is showing sublimation. Okay, it involves the sublimation. So it involves what? Sublimation. Okay, the first step involves sublimation from sodium, solid sodium to gaseous sodium atom. Next conversion is from gaseous sodium atom, that is NaG, okay, to gaseous sodium ion. Okay, so from your gaseous sodium, we are forming its ion. So this process is called as ionization enthalpy. This process is called as ionization enthalpy. Okay, so Na, which is so gaseous state, it gives Na plus. Okay, so it involves delta I. Next, third step is conversion of the gaseous chlorine molecule. So your chlorine molecule, which is gaseous state, it undergoes what? So which is a molecule. Okay, it forms gaseous chlorine atom. It forms two gaseous chlorine atom. So this energy change during this process, it's called as bond dissociation enthalpy. Yes, we have studied just now bond dissociation enthalpy. That is the energy which is required to break the bond. Okay. Uh, so this is a bond dissociation enthalpy. So it is given as Cl2 gas giving you 2Cl minus. Okay. Now half chlorine giving you Cl. Fine. So this is the about your third step. Next is conversion of this chlorine atom to chloride ion. So now your chlorine atom is converted, right? It should be converted into chloride ion. Okay, that is, so this process is called as electron gain enthalpy because it is having one electron extra, right? So this process in which the energy changes in the world is called as electron gain enthalpy. So now to form this packing of Na plus, so we have formed the Na plus ion as well as Cl minus. So this Na plus and Cl minus, it forms NaCl. Okay. So this energy process, energy change in this process is called as lattice enthalpy. So this is the steps. Okay. So these are the 5 steps. So these 5 steps, it is given by this particular diagram. You can see here the diagram. Yes. Can you see the diagram here? Okay, so this is the diagram, okay, which explains your Haber's cycle. Okay. Okay. What is entropy? Entropy is nothing but degree of disorderness, okay, or randomness in a system. So how it is given as delta S is equals to Q reversible. Okay. Nothing more here. Then entropy, just now entropy we have seen. What is entropy? That is a degree of randomness. Okay, disorderness or degree of randomness. Then what is second law of thermodynamics? Okay, it is stated as the entropy of the universe always increase during every spontaneous process. So keep in mind this particular second law. Then third law of thermodynamics, it states that the entropy of any perfectly crystalline substance becomes zero at absolute zero of temperature. Okay, so what is the importance of this law? That we can calculate the absolute value of entropy of pure substances from thermodynamical data. Okay, so we can, so by using this law, we can find the absolute value of entropy of pure substances. So Gibbs energy now. What is Gibbs energy? The maximum amount of available energy that can be converted into useful work. So it is given as G is equals to H minus Ts. Okay, so remember this. So this is the Gibbs equation, that is change in Gibbs energy is equals to delta H minus T delta S. Okay, so this is the Gibbs energy for a system, that is delta G system is equals to delta H system minus T delta S system. So remember these equations. So using this equation, we are going to solve the MCQs. Okay. So I'm just going on to the important things. Yes. So this one particular Gibbs energy change and equilibrium constant, how they are related? They are related by delta G naught is equals to minus RT ln of K. So if you remove, if you want to put the value, okay, so you can introduce here minus 2.303. Okay, that is delta uh, that is if you remove the ln, okay, if you introduce the log, then you have to put the value of equals to minus 2.303 RT log of K, okay, where R is your universal gas constant, T is the absolute temperature, okay, and for a spontaneous process, the value of K should be always positive. So these are the things, okay, so keeping this all things in mind, we are going to solve the questions. Okay, now. Okay, I think we have solved some 15 questions in the previous class. So we'll start with this. The Q is dash when heat is transferred from the surroundings to the system, and Q is dash when heat is transferred from system to the surrounding. Okay. So A is positive, negative, B negative, positive, C high, low, and D low and high. Yes. Yes, students, what is Q? Q is nothing but your heat capacity. Okay. So what is heat capacity when that is heat is transferred from the surrounding to the system, and Q is what when heat is transferred from system to surrounding. Yes. So when Q, okay, when heat is transferred from surroundings to the system, the Q will be positive. Okay. And when heat is transferred from the system to the surrounding, it will be negative. So which is the correct option, students? It is A. Okay, it is A. Fine. Okay, moving forward. Okay. Now, adiabatic expansions of an ideal gas are accompanied by adiabatic expansion of an ideal gas are accompanied by A, decrease in delta E, B, an increase in temperature, C, a decrease in delta S, and D, no change in any of the above properties. Akshaya has answered it as C. What about others? Adiabatic expansions of an ideal gas are accompanied by. What is adiabatic process? Adiabatic process is a where okay, it is a type of thermodynamic process. Okay, where that is it the transfer occurs. Okay, without transferring heat or mass between the system and the surrounding. Okay, so the adiabatic expansion of an ideal gas. So how it is accompanied? Yes, students, try answering. Okay. Nobody knows the answer. Fine, I'll tell you. Okay, so adiabatic expansion of an ideal gas. Okay, so when you're talking about adiabatic expansion, I've told you what is the meaning of adiabatic expansion now. So it is given as delta E is equals to delta Q minus W. Okay, so for adiabatic expansion, delta Q will be equal to 0. Okay, so what will happen? So delta E will be minus W. So because delta Q will be equal to 0, okay, so delta E will be equal to minus W. Okay, so negative sign, what it indicates? Negative sign indicates that there is a decrease in internal energy. Okay, so it indicates there is a decrease in internal energy. So which is equal to the work done on the system by the surrounding. So the answer is A, decrease in the delta E. Okay. So that is negative sign as it indicates the decrease in the internal energy, okay, which is equal to work done on the system by the surrounding. So it is A. Answer is A. Okay, understood? Okay. Fine. Next question. 2 moles of an ideal gas is expanded isothermally and reversibly from 1 liter to 10 liters at 300 Kelvin. The work done in kilojoules for the process is A, for 11.4 kilojoules, B minus 11.4 kilojoules, C 0 kilojoules, and D for 4.8 kilojoules. Yes, 2 moles of an ideal gas is expanded isothermally and reversibly from 1 liter to 10 liters. Okay. At 300 Kelvin, the work done for the process is. So how do you do this problem? Okay. See here, for your isothermal reversible process. Okay, for isothermal reversible expansion of an ideal solution. Okay, so when you're okay, so when you're considering the isothermal reversible expansion, okay, so it is a ideal solution is undergoing isothermally and reversible expansion. Okay, so what will happen? So that time your internal energy will be 0. Okay, when it is undergoing isothermal and reversible expansion. Okay, so your what internal energy delta U will be equal to 0. Okay, then Q will be minus W because it is reversible. Okay, because it is reversible, so Q will be minus W. So that will be equal to plus 2.303 T log of V2 minus V1. So this is a formula. Now we will add the value. Okay, so work done, it is given like this. So that is 2.303 nRT log of. So we'll add the value. So 2.303 N is, what is N? So put all the values of N, R, T, V2 and V1. Okay. So after solving this particular equation, you have to get the answer as 11 point minus 11.48. Okay. You will get the answer as minus 11.48. So put the all this values and you get work done will be equal to minus 11.48 kilojoules. Okay. So this is the answer. Fine. Next question. Okay. Next question. Delta H minus delta U for the formation of carbon monoxide from its elements at 298 Kelvin is. R is given as 8.314 joules per Kelvin per mole. So these are the values. Okay. So for the formation of carbon monoxide, so how carbon monoxide is formed? So carbon solid form plus half O2, okay, in the gaseous gives you carbon monoxide, okay. So delta N, okay, so the formation of this delta Ng, we don't know the formation of carbon from its elements are, okay. So delta Ng will write is equals to 1 minus half. Okay, so this is, we have to find the formation of this. So we'll take it as delta N. Okay, is equals to carbon is 1. This is half. So this will be equal to plus half. Okay, so this is equal to plus half. So delta H minus delta U. Okay, so that is change in enthalpy minus change in your internal energy. It is given as delta NGRT. So after putting this value, N is plus half into 8.314 into temperature is 298 Kelvin. See what you will get the answer. Solve this. So you should get this answer as 4 is 8, 2 1s are 2, 2 5s are 10, 2 7s are 14. So the answer, okay, it should be around 1238.75 joule per mole. Okay, so the answer is first one, A. The answer is first one, A. Okay, fine. Which of the following is an intensive property? A, enthalpy, B, entropy, C, density, and D, mass. Yes, which is the following is an intensive property? You know what is intensive property, what is extensive property. Yes, what do you mean by intensive property, students? Intensive property means what? It is a property of a matter that does not change, okay, as the amount of matter changes, right? So this is a bulk property. So what depends? Yes. So which of the following is an intensive property? It is density. Okay. So density is a intensive property because it is independent of the amount of substance and it depends only on the nature of the substance. So it is C. The answer is C. Okay. Moving forward, among the following, the intensive property is A, molar conductivity, B, pressure, C, enthalpy, and D, heat capacity. So A, AB, B, AC, C, ABD, and D, BC. So which among the following are the intensive property? Yes, which of the following are the intensive property? Enthalpy and heat capacity. Okay, enthalpy and heat capacity. So these both depend on the amount and are extensive. So these both are what? These are both extensive property because they depend on matter. Okay, they depend on the amount of substance. Fine, amount. So these both are extensive. So molar conductivity and pressure. Okay, so these are the intensive property. So option number A. Option number A. So molar conductivity and pressure, these are the intensive properties. Okay. Enthalpy and heat capacity, it depends on what? It depends upon the your amount. Okay, depends on the amount. So it is a extensive property. Fine. In a adiabatic expansion of a ideal gas. So what is the equation given for adiabatic expansion? It is given as, so in a adiabatic expansion of an ideal gas, you know that Q will be equal to 0. So delta U will be Q plus W. Okay. So delta U is equals to W, because your this is what Q is equal to 0. So for expansion of gas, you know that for expansion of gas, W will be equal to negative. Okay, for whenever it is undergoing expansion, your work done will be equal to negative. So it is always negative. So work done will be minus delta U. Okay, so option number A. So whenever it is undergoing an adiabatic expansion, okay, so delta U is equals to W, and work done is always negative. Okay, so this is the answer. Option number A. I hope you are understanding the things. Yes, is it clear? Whatever has been is been explained, is it clear, students? Which one of the following is an extensive property? A, viscosity, B, surface tension, C, temperature, and D, volume. So which of the following is an extensive property which depends on the matter? Yes, temperature. Does temperature depends on matter? No. Okay, that is a quantity of matter? No. Then your surface tension? No. Viscosity? No. Okay. So volume. So volume depends on the quantity of matter. Okay. So volume is the what? Volume is the extensive property because it depends on the quantity of matter which is present in the system. So option number D. Option number D is the correct answer. Okay. So these things we have seen. Okay, enthalpy or heat of reactions. What is enthalpy change also? Enthalpy of formation we have seen. Okay, enthalpy, standard enthalpy of reaction, how it is formed. Okay, yes. So based on that, we'll solve problem now. The delta H naught F for carbon dioxide, carbon monoxide, and water are minus 393.5, minus 110.5, and minus 241.8 kilojoules per mole, respectively. So the standard enthalpy change in kilojoules for the reaction carbon dioxide gaseous plus H2 gaseous, giving you carbon monoxide gaseous plus water gaseous are. Okay. A 524.1, B 41.2, C minus 265.5, and D minus 41.2. Yes. So this is a standard enthalpy change. How do you calculate it? So I'll show you how to calculate the standard enthalpy change. Okay. So carbon dioxide gas plus H2. So delta, so the formula is delta HR. Okay. Equals to. So the formation of delta HF naught of carbon dioxide. Okay. Carbon monoxide, sorry. Okay. Carbon monoxide plus delta H naught F of H2O, okay, minus delta H naught F of carbon dioxide plus delta H, that is the formation enthalpy, okay, of H2 gas. So these values are have, we have. So depending on that, we are doing. So carbon monoxide plus H2. Okay, it gives what you get carbon dioxide plus H2, right? From this. Then here, carbon dioxide plus H2. What you get here? Carbon monoxide plus H2. Is it correct? Understood? So like this, we are putting. Okay, like this, we are forming the equation. Now we'll put the values. So note that your delta H naught F of H2 gaseous will be 0. Okay. So this you have to remember that your delta formation of H2 gas will be equal to 0. So delta, this is enthalpy change of formation of carbon monoxide is how much? It is 110. So 110 plus delta H formation of water is minus 241.8. Okay, fine. So this in the bracket, then minus of delta H F naught of carbon dioxide is minus 393.5. Then plus HF or this formation of H2 is 0. Okay, so I'll not put it. Now solve this. See what answer you are getting. So after solving, this should come as minus 352.3 plus 393.5. Okay, minus minus it becomes plus. So the answer will be 41.2 kilojoules. So 41.2 kilojoules. It is plus 41.2. So it is B option. Is it so? Are you getting it? Yes. Yes. Are you getting the answer? So we have to substitute the values which have been given and we have to find the enthalpy change, standard enthalpy change, okay, for this particular given equation or the given reaction. Okay, fine. Next, the enthalpy of formation of two compounds A and B are minus 84 kilojoules and minus 156 kilojoules respectively. Which of the following statement is correct? A and B are endothermic compounds. B, A is more stable than B. C, A is less stable than B. And D, both A and B are unstable. Okay, so we are considering the enthalpy of formation of two compounds. Okay, we are forming the two compound that is A and B. So the enthalpies are given. Okay, so which of the following is correct? So A has an enthalpy of 84 kilojoules and B has an enthalpy of minus 156 kilojoules. Yes. So you can see based on the values, okay, based on the values, A is less stable. Okay, you can say that A is less stable because lesser the energy released in the formation of compound, lesser will be its stability. Okay, so when you are comparing your both the this enthalpies, okay, you can see minus 84 is less than minus 156. So you can say that A is less stable. Why? Because lesser the enthalpy, that is the lesser the energy which is released in the formation of compound, lesser will be its stability, okay, as compared to the other compound. So as compared to the other compound B, A is less stable than B. Option number C. Okay, option number C is the right answer. Is it clear? Yes, student, is it clear? Okay, so when we are considering the formation of two compounds based upon the values, you can see minus 84 is very less. So when you are saying that less amount of energy is released, that means the compound, okay, formation of compound, that is as the energy released in formation of compound is less, so lesser will be the stability, okay, as compared to the B compound. So option number C. Next. The enthalpies of formation of Al2O3 and Cr2O3 are minus 1596 kilojoules and minus 1134 kilojoules respectively. Delta H for the reaction. Okay, so this is a reaction that is 2Al plus Cr2O3 giving you 2Cr plus Al2O3 is. So the values are given, enthalpies of formation, and you have to consider this equation that is 2Al plus Cr2O3 giving you 2Cr plus Al2O3. Yes. So find out the enthalpy of formation here. So here again the delta H, okay, delta H you have to find it as, so delta formation of F of Al2O3, okay, minus delta HF of Cr2O3. Fine. So put the value of Al2O3. What is the value of this Al2O3? It is minus 1596 of minus 1134. Okay. So after solving, you get 96 and this is plus 134. So you get how much is C? 62936 and 5 minus 1 4. So minus 46 kilojoules. Okay. Minus kilojoules. Okay, so this is the answer. So just see minus 46, yes. So it is D, option number D. Option number D. Is it clear, students? Any doubts? If you have any doubts, any queries, you can ask your doubts, your queries in the chat box. Okay. So this is all depending on the formulas. Okay. So these problems are all depending on the formulas. We have seen these all things. Okay, entropy, we have seen what is entropy. It is a measure of randomness or disorder of the molecules of the system. Okay, it is denoted by S, capital S. So S delta S is S final minus S initial. Okay, what is spontaneous process? A process which takes place by itself under a given set of condition is called as a spontaneous process. What is Gibbs free energy? That also we have seen. That is the maximum amount of energy which is available for a system during a process that can be converted into useful work. So it is given as G is equals to H minus Ts. So Gibbs-Helmholtz equation delta G is equals to delta H minus T delta S. Okay, and for spontaneous process, delta G is always negative. Fine. So these are some of the points which you need to remember. So when you have delta H, delta S, delta G, what will be the condition? Okay, so when you have delta H negative and delta S positive, delta G will be negative. So spontaneous. So the reaction is spontaneous at all temperature. Then when you have negative, negative and your delta G negative at low temperature, so it will undergo spontaneous. When you have delta H and delta S negative, your delta G will be positive at high temperature and it undergoes non-spontaneous. Okay. Then delta H and delta S is positive and your delta G is positive at low temperature, it undergoes non-spontaneous reaction. Then when your delta H and delta S are positive and delta G is negative at high temperature, it undergoes spontaneous. So when your delta H is positive, delta S is negative, your delta G will be positive and it is non-spontaneous at all the temperature. Okay. Now what is standard free energy? Okay, what is standard free energy? Standard free energy, it is a Gibbs energy change for a process at 298 Kelvin and 1 bar pressure in the reactants and in their standard state. Okay, which can be converted into a product in their standard state. So this also we have seen. Okay, so one last problem, I guess. Okay, last two problems we have. So for the reaction, H2 gaseous plus half O2 gaseous giving you H2O. So delta H is equals to minus 285.8 kilojoules per mole. Delta S is equals to minus 0.163 kilojoules per mole. What is the value of free energy change at 27 degree for the reactant? So the values are given. So how will you solve this? So you know that free energy is given as delta G is equals to delta H minus T delta S. Okay. So after putting the value, change of enthalpy is given as minus 285.8 and delta temperature is 27. Okay, temperature is 27. So 273 plus 27, 7, 8, 9, 10. 7, 8, 9, 10. So it is 300. So it is 300 into, okay, then delta S is minus 0.163. Okay, now put this value. So minus 285.8 minus 200, that is 300. So what will be this? 300 minus this, you get it as into, just a second. 300 into 0.163. Okay, it comes to 48.9. So minus and minus will become plus. Okay, so after solving this, you get minus 236.9 kilojoules per mole. So see your answer, it is option number A. Option number A. Is it clear? Okay, fine. So the last problem. Consider the following equation in the automobile. So this is the equation. Signs of delta H, delta S and delta G respectively will be. Consider, so what is the answer? So options are A positive, positive, negative, B negative, positive and negative, C negative, positive, positive, D positive, negative and positive. So you have to consider this following reaction in an automobile. Okay. So what will be the signs of change in enthalpy, change of entropy, and your free energy, Gibbs free energy. So you know that change in enthalpy will be always negative because combustion is always exothermic. Okay, because the combustion will be always exothermic, so your delta H will be negative. Then when you are talking about delta S will be always positive because there is increase in the number of gaseous moles. Okay, as there is increase in the number of gaseous mole, so because of that delta S will be positive. Okay, and delta G. Okay, delta G is negative because there is a spontaneous change. So option number B. Option number B is the right answer. Yes. Fine. So okay. So by this, we have completed the chapter thermodynamics. Okay. Any doubts? Yes. Any doubts in today's session, students? So this completes our chapter thermodynamics. So in the next week, we are going to start with the equilibrium. Okay. So we have left with the chapter equilibrium. So that particular chapter will be dealing in the next week. Fine. No doubts there? Fine. So I shall end the session here. I hope whatever the things have been covered today, just go through them. Okay, try to solve some more questions, some more MCQs on this. So this will clear your doubts. Okay, whatever the doubts are there, so it will just clear. So it will give you confidence. Okay, to solve the problem. So after seeing this, whatever the questions, okay, so similar types of questions you can solve. So it will boost some confidence in you. Okay, so you will be confident enough to solve this questions. Okay, from this particular chapter. Fine. So I shall end the session here. So in the next week we'll be starting with the new topics. So thank you. Have a good weekend.